so now we're going to graph, but it helps if you know the parent functions of each of these functions. Now in number 1, your parent function is a parabola, and that is at y is equal to x squared. So your parent function for a y is equal to x squared graph, you have the points at 0, 0, 1, 1, negative 1, 1, and 2, 4, and negative 2, 4. This is the parent function, okay? And it helps if you know the parent function is always the same, so it helps if you know that parent function. Now I'm going to teach you how to find the parent function just in case you don't remember or don't know how to. So if we create an x and y table, we are going to find our parent function for when x is negative 2, negative 1, 0, 1, and 2. If I put negative 2 in for x in my parent function, a negative 2 squared is a 4. If I put negative 1 into my parent function, a negative 1 squared is a 1. If I put 0 in, a 0 squared is a 0. 1 squared is a 1. If I put 2 in, 2 squared is a 4, which gives us these points of negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. This is our parent function. Now what we're going to do is we are going to graph the new function from the parent function using transformations. So each of these points on my graph are going to be moved over 1 unit to the left, and then we're going to have a vertical stretch of 3. All right, so if you have a vertical stretch or compression, your slope of your graph is going to be your k value over 1. This is my k value, which is 3, so my slope is going to be, since it's a vertical stretch or compression, my slope is going to be 3 over 1. So let's graph this now. I'm going to, my vertex of my parabola is 0, 0. I'm going to move that over 1. Now, on my parent function, my slope between my first and my second point is up 1 and over 1. For my new function, I'm going to go use my new slope, which is up 3 and over 1. And then remember, a parabola has an axis of symmetry, so now I can reflect that second green point over that axis of symmetry to find another point on the graph. Now the slope between my next two red dots is up 3 and over 1. So what I would do is I'd multiply the rise by my new slope. So instead of going up 3 and over 1, I'm going to go up 3 times 3 over 1, so a 9 over 1 is my slope between my next 2 points. And I can't fit that on my graph, so I'm actually going to just leave my green graph looking like this. This is what my new transformation looks like. All right, so that's parabolas, and if we look at number 11, that's also a parabola, so let's just get that one out of the way. My parent function's at 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. These are all the points for my parent function. Now what I'm going to do with this one is I'm going to first reflect this over the y-axis. Well, reflecting this over the y-axis puts this blue point on top of this blue point here. So those two just flip around. And this point here and this point, those two just flip around, and this vertex just stays where it's at because it's already on the y-axis. So the reflection over the y-axis for this parabola doesn't actually move the parabola anywhere. So we don't have to worry about doing that reflection because of that. Now I'm going to do my translation. I have a horizontal translation of 3 to the right and up 1. So I'm going to move each of these points 3 to the right and up 1, 3 to the right, and up 1, 3 to the right, and up 1, 3 to the right, and up 1, and then lastly 3 to the right and up 1. This is what your new parabola looks like. All right, so again, it helps if you know the parent functions for these graphs. So if we look at number 8 now, we have an absolute value function. So let's first explore what the parent function looks like for that one. So looking at the parent function of an absolute value function, absolute value functions are a little bit easier to work with than quadratic functions. So we're going to create an x and y table to show you what the absolute value parent function looks like. I'm going to use the same x values of -2, -1, 0, 1, and 2. So if I put -2 into my absolute value function, the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So graphing this on my graph, this is what your parent function of an absolute value graph looks like. And again, it really helps if you know what the parent function of each of these look like. And again, if you don't know, you can always use that x and y table to help you figure it out. Now, for this one, remember that if you have a vertical stretch or compression, your slope is k over 1. So here I do have a vertical stretch slash compression. My slope then would be 2 over 1. So I'm first going to I'm going to move all these points over 2 units to the right, 2 units to the left, 3 units down. So my bottom point here is going to be over 2 units to the left, 3 units down, like this. And then now, essentially what I'm going to do is I'm just going to use my slope of 2 over 1. So I go up 2 and over 1, up 2 and over 1, because the slope for an absolute value graph is consistent throughout. If I look at my points, my slope between my first 2 points, it's up 1 and over 1. And between my second 2 points, it's also up 1 and over 1. So I could use the same slope throughout, going up 2 and over 2, up 2 and over 2. Now I could also then just, an absolute value graph also has an axis of symmetry. So now I can just reflect those blue points over, like so. And this is my new blue graph. All right, I have another absolute value graph down here. However, this one, I don't have a vertical stretch or compression. On this one, I have a horizontal stretch. And when you have a horizontal stretch or compression, your slope is actually going to be 1 over the reciprocal of k. So here, my slope is going to be 1 over the reciprocal of 1/2, which the reciprocal of 1/2 is 2. So my slope is 1/2. So what this means, I'm going to graph my parent function for this absolute value graph, which it's the same for all absolute value graphs. And now what we're going to do is we're going to move our vertex over 1 unit to the right. And now I'm just going to use my slope of 1/2, which means I go up 1 and over 2, up 1 and over 2. And with an absolute value graph, you do have an axis of symmetry running through your vertex. So reflecting my 2 points over, I wind up with a point here, and I wind up with a point here. And this is what your new graph looks like. And you are more than welcome to erase your parent function after you graph it, but I have not been. All right, and then number 9, we are going to do square root parent function. So the square root parent function is just y is equal to the square root of x. And so now I'm going to have, again, it helps if you know what the parent graph looks like, and it might help to remember these parent graphs. Because if I do -2 and -1, the x values that I've done on the other parent graphs, the square root of a negative number cannot take place. So I'm not going to use those. If I do 0, if I put 0 in for my parent function, the square root of 0 is 0. If I put 1 in, the square root of 1 is 1. But if I put 2 in, I get a very long decimal in my calculator, so I'm not going to use 2. And 3, the square root of 3 is also going to be a very long decimal. However, the next point, 4 is a perfect square. If I do the square root of 4, I get 2. So I'm going to graph these 3 points only for the square root function. 0, 0, 1, 1, and 4, 2. And so this is what my parent function looks like, just like so. And now I have first a reflection over my x-axis, which means all of these points flip over my x-axis. So this point stays, but the 0.11 now goes here, and the 0.42 now goes here. And this is my new function just with the reflection part. But now I'm going to translate that 5 units to the right. So each of these points gets translated 5 units over to the right. And this is going to go off the graph, but it's going to look something like this. So that blue graph is my final graph after I did the reflection and the translation. And then lastly, a cubic graph. I'm only going to show you 3 points on a cubic graph. Technically, actually, I am going to show you all of them. Sorry. So the parent function of a cubic graph is y is equal to x cubed. And if I put negative 2 cubed in, I get a negative 8. Negative 1 cubed gives me a negative 1. 0 cubed gives me a 0. 1 cubed gives me a 1, and 2 cubed gives me an 8. So these are my values for the parent function of a cube graph, a cubic graph. Well, negative 2, 8 goes off my graph just by 1 unit, so I guess we can draw it. Negative 1, 0, 0, 1, 1, and 2, 8. So this is actually what your cubic graph looks like. And I apologize, I should have did that dotted. Okay, so now for this one, all I'm doing is I'm translating it up 4. So all these points get translated up 4. And the top one is somewhere up here. But this is what your new graph would look like after all the points are translated up 4. And that brings us to the end of this lesson. So again, it really helps if you know the parent function and what the parent function looks like to be able to do these transformations. Now we will learn more about these slopes, these vertical stretch and compression slopes and the horizontal stretch and compression slopes in the next standard. But that brings us to the end of this lesson.